Okay, so now how do we use all that information? Determine two angles between 0 and 360 associated with each of the following. Round to the nearest degree. Sine theta equals positive 0.29. Here's a graphical solution. The graphical solution shows the graph of sine theta. And what we're looking for is what values of x, what values of theta, what domain values will give me this range value. That's what sine theta looks like. We know it goes up to 1, down to negative 1. So it's going to pass through 0.29 around here and around here, giving me two answers in the domain. Now, something to notice here, it's also going to give me 0.29 twice. It's going to hit it here, and it's going to hit it here. Okay? But that's negative 0.29. I don't want those. The question asked for positive 0.29. That's going to become very important in a minute, so pay attention to that. Okay, so I've got two answers in here. My calculator only gives me one answer. It gives me the smallest answer, and it's going to give me theta equals 17 degrees. So it's giving me this one right here. So if I take 17 degrees and plug it into my calculator, for sine, I'm going to get approximately 0.29. The question is, what is the other answer? We know there's another answer here, and the question is, where else? If I look at the graph, I can tell what quadrant it's in. It's pretty easy. It's going to be in quadrant 2. Looking at my answer, at my graph, I can tell it's going to be in quadrant. That's quadrant 1, my first answer. That's quadrant 2. This is going to be quadrant 3. That's going to have a negative answer. And this is quadrant 4. That's going to have a negative answer. So instead of drawing the graph all the time and figuring out where my other answer is going to be positive, I use the CAST rule. The CAST rule is a quick way of taking this information and putting it into a simpler way of writing it down. So I draw my axes, creating quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And then what I do is I draw my first solution. So 17 degrees is right here. So coming up from the initial arm to the terminal arm, that is my first solution. So the question that I ask is, where else is sine positive? Why positive? Because the original question said positive. You got to be careful of that, because I will get answers for where is sine theta equal to negative 0.29 in here, but I don't want those. So the answer to our question is quadrant 2. We know that quadrant 2 is positive for sine. So we draw our first solution. So this is 17 degrees. This is what we call our related acute angle. We talked about that in the earlier video. Related acute angle. What does the word acute mean? Acute means less than 90. Okay, so it's going to be the angle that's less than 90. And we want to know what the rotational angle, starting from this initial arm, is to get to this terminal arm. So if this is 17 here, normally you'd go 180, but you're not quite going 180. You're not going that 17 degrees. So it's 180 minus 17, which is 163 degrees. And that gives you the two answers. So if you plug in 163 into sine, you're going to get approximately 0.29. And if you plug in 17 into sine, you're going to get approximately 0.29. And it gives you your two answers. And that's all there is to it. Pretty simple. All right, I'm going to stop this and come back, and we'll do the next example.